Good day, everyone, and welcome to Women in Data Science, Trinidad and Tobago. This is the WiDS 2023 Datathon tutorial sessions, and this is our second tutorial session presented by the WiDS TNT team. I am Dr. Addison, and I will be moderating today's session with a few of our mentors. So just to remind some of you who may not have been in our previous sessions, these are some basic background theory to support the WiDS 2023 Climate Challenge. And it involves a data set hosted on Kaggle. Of course, it's been live from the 4th of January, and it goes until the 1st of March. And it's involving the adaptation of climate change by improving extreme weather conditions. Just to give persons a little reminder in terms of the timeline of where we are. So today we are going to look at an introduction to machine learning. And in the last few sessions we had the information session on the 7th, and last session, our tutorial 1, we looked at an introduction to Kaggle and data science using Python. So for persons who would have missed that session, it's available on our YouTube channel. And of course, if you are in our mailing list and on Slack, you'll be able to access the video recording and also the notebooks for these sessions. As we move along, I'm just going to remind persons that next week, we'll be hosting an open session for team formation for persons who are interested in participating in the challenge with our mentors. Of course, remember, it's not only open to nationals from Trinidad and Tobago. We are open to persons from anywhere in the world who would like to compete on our team. And we will be able to select persons for various teams based on your skill sets from absolute beginner to advanced. So we welcome anyone who's interested to participate in these sessions. And we would also like to remind you about our workshops and our regional events coming up in March, particularly the February Datathon workshops. These are webinars, and you would find that you would have a complete overview of the entire climate challenge. We'll be hosting that on the 4th of February. So we will have an international speaker, Ms. Usha Rengaraju. She is the head data scientist at Exploratory in Australia. So she will come in on the 4th to talk about the data challenge and the data set, and to give everyone a very high level overview of how to do some of the analysis similar to what we have been doing in notebooks currently. She will actually show you all how to do it from scratch, from beginning to end, in a really nice, concise webinar on the 4th. Following that, we will have some data science methods at a glance on the 11th of February, and we'll also have one of our local speakers and an international speaker. All the information is on our website, and the registration links are there. So you can actually access those currently and be able to sign up for them beforehand. So I think those 3 sessions in February will really help you to hone in on all the specific tasks that you would need to cover, particularly for the persons who are serious about competing and would like to win all the fabulous cash prizes globally and locally. In fact, next session, when we have our open session, we will discuss with you some of the prizes that are available for the different teams who participate in the challenge with us. So I know I had mentioned to you this really handy predictive this word cloud now with all these predictive words or descriptive words that persons would have used to describe machine learning. For those of you who just joined us, feel free to access this in the chat, and I will give persons a couple minutes and then show you some of the live results. So just give persons a few minutes again. And I'm going to just share these results. Let me know if you are you seeing my screen currently? Are you not seeing the link? Sorry, Krista. Rihanna, just share the link again. So far, this is what we have. I'm seeing some really descriptive terms here. So yes, great. Thank you, Ray. So for those of you who were with us last week, we had this exciting look at the word cloud and the formations in terms of, remember, you can actually enter more than one, I think up to 3 per person in terms of what you think about when you hear machine learning. In terms of how the word cloud works, remember the largest word or words represent the ones that will have the highest frequency, or said the most. So in this particular one, I'm seeing predictions and followed by algorithms. So I'm seeing a lot of great terms, tensors, wow, statistics, robotics, efficiency. We have a lot of intermediate to advanced people in this room currently, as far as I see. Data-driven problems, intelligence, I'm really happy to see that. It's very exciting. Backpropagation, very nice, right? So very nice to see everybody getting involved and letting us know what they think. So I'm just going to switch again to my slides and actually give you all just a kind of a high-level overview of data science in terms of a graphic. And you could see the progression here of how it goes from an ordinary system using AI and then machine learning. And what is going to happen here, our mentor is going to actually give you it in more of a breakdown, but the high-level overview would be that it learns, it predicts, and then it also improves. And that's essentially what we're going to be doing in this data challenge. So at this point, I'm going to stop sharing and I'm going to allow our mentor liaison, Shannon Ray. She's going to come in and go through the segments that we have planned for today. So Shannon Ray, I'll stop sharing and hand it over to you.
So, hi, good morning, everyone. Can you all see my screen?
Yes, we can.
So, welcome to our second tutorial. So I'm just going to give you guys a brief introduction to the topics that we're going to touch on today. So by the end of this session, you guys will be able to perform an exploratory data analysis. And you'll do so by learning about the necessary Python libraries. You guys will also learn how to load and clean and explore the data. Next, you guys will learn how to use different types of machine learning techniques. Namely, we're going to focus on linear regression, and we're also going to touch on different types of supervised learning. Lastly, and most importantly, you guys will learn how to evaluate the performance of your machine learning models. So you guys will learn about metrics and techniques that you can use to choose the best model. So I just wanted to quickly go back to the life cycle of a data science project. So last week, we would have spent a lot of time on what we call business understanding or building the domain knowledge, understanding what the problem is about. This week, we're going to be focusing on steps 2 to 5. So first, we're going to understand our data. Then we're going to prepare our data. We're going to spend a good amount of time on this step because I'm sure you might have heard or seen the phrase garbage in equals garbage out with respect to machine learning. What that means simply is that you can't feed a model bad, quote unquote, bad data and expect to get excellent results from it. So you really want to spend a lot of time prepping your data so that your model can work well. Next, we're going to look at different types of modeling, as I mentioned before. And lastly, we're going to evaluate our model. So just to quickly touch on what are the different types of machine learning, as you can see from this infographic here, first we have supervised learning, which we will go into depth in the next section, and that can be broken up into regression problems, and classification problems. Next, we have unsupervised learning, which in contrast with supervised learning, supervised learning, it deals with making predictions based on a data set with a particular target in mind. In contrast, unsupervised learning will not have a particular target in mind from the go. So what it does is it groups the data into clusters based on their level of similarity. So within unsupervised learning, we can go into clustering, which deals with actually getting outputs from the data, or dimensionality reduction, which is a method of preparing the data. The last type of learning I wanted to touch on is reinforcement learning, which deals with learning from mistakes essentially. So it's a training method based on rewarding desired behaviors and punishing undesired ones. So what do we mean by learning? A computer program is said to learn from an experience C with respect to some class of task C and performance measure P. If its performance task C is measured by P, it improves with experience C. Now I know that can sound kind of confusing, so I wanted to just give you guys an example of what that would mean. So here we have a kind of classic machine learning example where we're trying to interpret handwritten numbers into standard numbers. So the task C would be recognizing and classifying handwritten numbers within images. So the performance P will be the percent of numbers correctly classified. And the training experience would be the data set itself of handwritten numbers alongside its given classifications. So we talked a lot about prepping data. So now I'm going to pass you over to Nicholas, who will give you guys an interactive demonstration of how we can do this.
Good morning, everyone. My name is Nicholas Smith. Just let me know if you can hear me clearly.
Good morning. Yes, we can.
Okay, great. So today I'll be doing a presentation on the exploratory data analysis. I'll give you a nice interactive introduction to it. We'll be sharing with you a Google Colab notebook where you can interact with the data as well. So give me a few seconds. Let me share my screen.
Before Nicholas begins, I'd just like to let you all know that although we have female mentors, we do have some male mentors, and today we decided to actually showcase them. So Nicholas is one of them, and you will also hear from Shankar a bit later on. So we're really happy to have the males supporting us on the team. So Nicholas, take it away.
All right, thank you for that. So introduction to data, exploratory data analysis. What is exploratory data analysis? So one second, sorry. So this is an approach to analyzing and understanding a data set. It is a method of discovering patterns, relationships, and insights from data through visual and statistical means. This approach provides a way to summarize and make sense of large and complex data sets. And this is often the first step in the data science process. What is the goal of exploratory data analysis? So simply put, to assist in identifying important features of the data. And it is also to encourage data analysis before making any assumptions on the data set. What are features? These would be the characteristics or properties of the data that are used to describe, measure, and predict something. Some techniques in EDA or exploratory data analysis would be visualization, descriptive statistics, and data transformation. In visualization, there will be graphs that we will plot to see how the relationship is between different features or columns in a data set. Descriptive statistics comprise of mode, median, and mean. and a couple other statistics that we will go into that you can research on your own. And data transformation, scaling, normalization, and aggregation. So our journey, beginning with exploratory data analysis, there are quite a few steps to follow. Everybody has their own list of steps, but there are similar steps that everybody do follow. So sometimes there may be more steps, sometimes there may be less steps, but these are some useful steps that I have aggregated and compiled into a list for us to follow for this data set. And this data set is the Titanic data set. So the first step, define the problem. You want to answer the question, what sorts of people were most likely to survive? The second step would be to import the important libraries that we will need. In using Python libraries, there are 4 libraries that we can use: pandas, numpy, seaborn, and matplotlib. Pandas allow us to manipulate the data. Numpy is for us to do data analysis on the data. Matplotlib and seaborn are both used for visualization, but matplotlib is more of a low-level library that provides a lot of control over the appearance of the plots, while seaborn is a high level, and this would be for beginners. It provides less control, but a simpler way to interact with the data. The next step we have would be to load the data. We'll be using the method readCSV from the pandas library to read the CSV data sets that we would upload into our Google Drive. And for exploring the data, we'll be using methods not limited to head, tail, info, and describe. These methods would allow us to explore the data a lot easier through Python. For data visualization, we'll be using matplotlib and seaborn to create histograms, bar charts, scatter plots, and heat maps. There are a lot more graphs that we are able to plot with it, but these will be the simple charts that we use. And then our last step will be data cleaning. After understanding the data through visualization and exploring, we can then begin data cleaning, and a process of that will be data imputation. So our next step will be define the problem. In the Titanic challenge description on Kaggle, there's a description tab that we can view the overview of the challenge. And below on the last paragraph, they say, in this challenge, we ask you to build a predictive model that answers the question, what sorts of people were more likely to survive using passenger data, i.e. the name, age, gender, socioeconomic class, etc. Next, importing the libraries. This is a quick snippet inside the Google Colab notebook of how we will be importing the libraries. We'll be using numpy, pandas, matplotlib, pyplot, and seaborn. Inside the Google Colab, they will have these links to the documentation that you can go into further on your own. You'll be loading the data into a data frame. I will show you how to connect to the Google Drive. And then from there, you will upload the CSV to your own drive. You should have at least 15 gigs available in your drive, hopefully, if you haven't used it all as yet. And we will be changing the destination on the Google Notebook to the destination where you have the data in your Google Drive. We'll be exploring the data using describe. This is a snippet of what happens when we use the describe method on the data set. This is on the training data set. And as we can see here, there is a table with the statistics of count, mean, standard deviation, min, 25, 50, and 75%, and max. The count would be the number of non-missing values in the series. The mean would be the arithmetic average of the values in the series. The standard deviation of the values in the series. The min would be the minimum value in the series. The percentages, 25, 50, and 75. These separate the 25%, lowest 25% of the values, the lowest 50, and the lowest 75. And then the max, which is the maximum value in the series. These statistics provide a general overview of the distribution of the values in the series and can help identify patterns and trends in the data. For example, the mean and standard deviation. This can be used to identify the center and spread of the data, while the min, 25, 50, 75, and max can be used to identify the range and skewness of the data. The skewness is a statistical measure of the asymmetry of the distribution of the data. Now, there will be some questions we would like to answer as we are exploring the data. Some questions are like, which features are available in the data set? Which features are categorical? Which features are numerical? Which features are mixed data type? Which features may contain error or typos? Which features contain blank, null, or empty value? What are the data types for the various features? What is the distribution of numerical feature values across samples? And what is the distribution of categorical features? So next, there are other functions called by info and head. The info function, this provides a summary of the data frame or series. And the head, this is used to get the first n rows quickly to test and view what the data is comprised of.
Nicholas,
So sometimes there may be, yeah?
Nicholas, sorry to interject. Are you showing other slides? Because we only see in the
No,
explored.
no. I was
Okay,
just
sure.
going off. Yeah.
Okay, great. Go ahead.
And the info function would be to display the first 5 rows, because sometimes maybe it's hundreds of thousands of rows in a data set. So now moving on to the data visualization, I'll be showing you different graphs visualizing the data. Here would be a snippet of code that I ran displaying the histograms for each of the columns in the data set. This is very small, but as we go into the notebook and as we go into different functions, we can create single histograms for each column. This was just to show all the columns in one. So there's passenger ID, they survive, P class, age, part, and SID or spouse. When we go into the notebook, I'll show you what they mean by the passenger ID, survive, P class, and age, etc. The next one will be heat map. This is visualizing the correlation of numerical data in the Titanic data set. Here we can see the null values, the distribution of the null values for the age and cabin. And there are also null values for embarked, but there are only 2, so it doesn't really show up here. So we can see there's a lot of missing data for the cabin, and not as much, but a lot of data missing for age. We'll be cleaning the age and embarked in the tutorial next. Next one will be the bar graphs. This will be visualization, the distribution of some features in the Titanic data set. This is the survive column of feature in the data set. As you can see, a lot of 500 approximately that did not survive, and approximately 300 or more survive. And P class, which is the passenger class or the class of the ticket that the passenger bought. 1 is first class, 2 is second class, and 3 is third class. As you can see, there were a lot of third class tickets purchased. And then data cleaning. After understanding the data format and visualizing the data, we can we can check for the missing values, and duplicate values, and clean the data accordingly. One form of cleaning data is data imputation. This is the process of replacing missing values in a data set. Here's a snippet of the heat map from before displaying the null values in the data set. And this would be the heat map of it after data cleaning. This snippet right above that says the number 8 right here, this is where I added the mean of the ages from the data set to the rest of the ages that were empty. And afterwards, as you can see, there are no white boxes or lines. And now I'll be moving on to the notebook. So let me stop sharing. One second. And let me know if you can see the notebook. Everybody can see the notebook?
Yes,
Everybody
we can.
has access. Okay, good. Everybody
So
has access to the notebook.
Rihanna is going to share that link in the chat for you all, so you can bring up the same notebook he has there.
All right, great. So when you are on the notebook, on the left-hand side, there is a list of items. We're going to click the folder here, and then mount drive. This would allow us to connect to the Google Drive.
Right, so it's in the chat for everyone, so you can open it up.
Yeah. All right. When we click it, they will ask for permission. You will just say connect to the Google Drive. And while that is setting up, I'll show you. I'll send this in the chat as well. This will be linked to Kaggle, where you can access the data. There's a tab right here where you can click on data. And on the right-hand side under Data Explorer, we can click on these CSV files. And when we click on it, it will pop up on the left-hand side here, right under View More. And we're able to download the CSV file with this download icon here. So we will download the 3 CSV files. After clicking the download, after we download it to the desktop, I already have it downloaded, so I wouldn't download it again. After all 3 are downloaded, we'll go to our Google Drive and upload it.
Okay, so let me just jump in and ask, is everyone able to access the file? Do you need a couple minutes to download? Let us know in the chat so we'll know the pace, so Nicholas can guide you. If anyone is having any difficulties whatsoever, please feel free to let us know in the chat. If you need us to slow down, if you need us to repeat anything, we're here to help. So I'm not seeing anyone seeing anything, so I'll let Nicholas continue. What file to download, Loria is asking. So you just want to go that over one more time, Nicola?
Sure, no problem. So hopefully you're able to access the Kaggle link in the chat. And when you navigate to the link, it will show you, it will direct you to the overview page. You're able to click data. And when you click data, you will scroll down just a little bit until we see Data Explorer. And when we see Data Explorer, we will click on the CSV files here, one at a time, and then we will be able to download it on our desktop. After we download the CSV files on our desktop, then we'll be able to upload it to our Google Drive. Yeah.
Okay, so we downloaded all 3. Yeah.
Okay, no problem. And once it's uploaded to the Google Drive and you're connected the Google Drive to the Google Notebook, on the left-hand side here, how do you upload to the Google Drive? Sure, hold on. So when you navigate to the Google Drive homepage, you'll click New. You're able to see the Google Drive homepage, right?
Yes. So we
Okay.
want to, Anisha is asking how to upload to the Google Drive. So this is the step you're doing now, right?
Yeah.
Okay, great.
So we'll click the new button they have on the top left, sort of, and we'll click file upload, and then we will navigate to whichever directory we downloaded the files from. And then when we click on it, we will press open, and it will upload it to this path here.
I suspect most of you may go to the downloads folder, Nicholas. For most people, I don't know the different systems if it would go to a different folder.
When you click on it and you click download, you can, pop up, you can choose which directory you want to go to.
Right.
When you check here, sometimes it will say download a desktop. Make sure and take note of that so you remember where it is downloaded.
Excellent.
Yeah.
Anybody has any problems navigating? Let us know in the chat.
Anisha, you understood? Everything good?
Yes. Okay, I think you could proceed. And if anyone else has any problems, let us know.
Okay, no problem. So after we connected,
he said,
let me show you up.
Yeah, go ahead.
No problem. So when you navigate to the Google Drive, there'll be a button called New. We'll be able to click on it. And when we click on it, you will click on File Upload. And where we remember that we downloaded these CSV files, we will navigate to that specific directory. If it's in desktop, we will go there. If it's in downloads, we will navigate to there. Then we will click on the file itself. This is the PNG. I don't have the CSV here. But you just click on the file and you press open. And then it will start on the bottom right-hand corner saying that it's uploaded. And then it will say upload complete when it's finished. For me, the file's already inside of the folder I have here. Yeah.
Faith has a great question. She's asking, do the downloaded files need to be in the same folder or directory as the Collab notebook? That's a good question, Faith.
It doesn't need to be, but it is recommended to keep everything neat because through the code, you're able to put the specific path to the file. But it will best practice to put it in the same folder as the Collab notebook.
Very nice. Answers your question, Faith?
Great. No problem. All right. Once the files are uploaded to Google Drive and we are connected to Google Drive on Google Collab, there will be a folder called Drive. This represents Google Drive. When we click the arrow to expand it, you will have My Drive. And then it may take some time to load all the folders. I have a lot of folders. And as before, my data was inside collab_notebooks. So I will expand here. And then I had it in the Titanic data. And I'll expand here. And this is the data here. So inside the notebook, there is a brief rundown of exploratory data analysis. We could always refresh our memory as we're going through the notebook. This is an approach to analyzing and understanding data sets. It's a method to identify patterns, relationships, and insights. And it's often the first step in data science. So beginning with exploratory data analysis, we're going to import the necessary libraries. We're going to load the data. We're going to explore the data. Then we're going to do some data visualization and data cleaning. So here, we will have the code cell to import the libraries that we wanted. And the good thing about Google Collab, most of the libraries are there, so you can just similarly follow this outline and import any other library you'd want to. For this tutorial, we'll be using NumPy, Pandas, Matplotlib, and Steep1. Just a quick here, this as is an alias for NumPy. So instead of having to write NumPy all the time, I just need to write NP instead. That's the purpose of this as NP, as PD, and as PL. Makes it quicker to write out the code. So now here, this is where we are loading in the data. For me, this is the path to where I uploaded the CSV files. This will be different for you depending on where you uploaded it. So it'll give you like 2 minutes to change this on your side to the path where you uploaded the CSV file. If there are any issues, you could send a message in the chat and we can help you.
Okay, Loria. Loria wants a little bit of a backtrack, right? It's fine, Loria.
No problem. How far back, Loria?
Sorry, it's just easier to speak. Is that okay?
Yes, sure. Go ahead.
Okay. I had to log back into Keep Kaggle, so that took me a minute. So I missed the part about after I download everything, I'm uploading it to Google Drive, my personal Google Drive.
After you upload it to Google Drive, yeah.
My personal one, yeah?
Yeah.
Okay. Thank you. And then I need to load up Python.
You wouldn't need to load up Python once you access the Google Colab notebook. It already has Python there for you.
Okay.
So you have the link to the EDA practice notebook, right?
That's the one that's on the screen, yeah.
Yeah. Okay, and when you click on, when you have this here, do you have the option to edit or do you have the option to copy?
Where would that be?
Check on the top right-hand side.
Top right, editing. It's in editing mode.
Okay,
Yeah.
1 second. All right, so if it's in editing mode, I would like everyone to go on the file option here and click save a copy in Drive. And after you have done that, you'll take a couple of seconds creating a copy. You'll go into a new tab. And then you will have your own copy of the EDA practice. So if I go in my Drive, and let me see, yeah. So it usually ends up in the suggested. There'll be a copy of EDA. And then you'll be able to access it from here in your own Drive.
So how is everyone doing so far? I'm hoping everyone is okay up to this step. Okay, Nicholas, I think you could proceed.
Okay. All right, good. So now that we have it connected, we will run the first cell. This is always important to run the first cell to import all the libraries. Next, after we updated the path or the destination where we have the data sets, we will run the second cell. And what this does, it takes the data from train, test, and gender submission and assign it to variables called Titanic train, Titanic test, and Titanic solution. Now, moving on to the next cell, we have understanding the nature of the data. We have the info function, which provides a summary of the data frame or series, including the number of null values, the data types of the columns, and the amount of memory used. This can be used to get a quick overview of the structure and contents of a data frame. So when we run this, this will be for the training data set. As you can see here, all the column names and the count of the non-null values. So there's 891, and in the age, there's only 714, carbon 204, and the embarked 889. So as you can see from here, there are a couple columns that have missing values. You can also run it for the test and solution, just to get an understanding of how that is. So as you can see in the training, there are 12 columns. In the test, there are only 11. And for the solution, you can see there are only 2 columns. Now moving on to the scribe. In pandas, this is used to generate descriptive statistics of a numeric series. So when we use the describe method or function on the Titanic train, it will show the descriptive statistics for 7 of the columns. This is because out of all the columns, there are 7 columns that only has numeric data in it, which will be passenger ID, survived, passenger class, age, sibling spouse, part, and fare. We will also use the describe on the test dataset to see. Now you can see that there is a missing column from here to here. This has survived and this doesn't. And then we can see in the solution, there's only passenger ID and survive. So this will give us a good understanding of the data sets that we have at hand. Then we have the head function, which gets the first n rows. By default, n is 5, but we can add a value, an integer value inside the brackets to get any amount of rows that we would want to. So as we can see, there are 5 rows. If we enter 10, it will display 10 rows. And similarly, there's a method called tail, which allows us to get the last n rows, or the default value is 5, so the last 5 rows. When we run this cell, we can see we're getting the last 5 rows of the training data set. And we can add the number value 10. And it will provide the last 10 rows in the data set. Now moving on to, hopefully everybody is up to here, not lost. Anybody's lost, everybody's good.
Any questions so far for Nicholas? No? Okay, you see, Nicholas
okay.
is doing such a great job so far, so continue.
Okay, so next step will be visualizing the data set. These are some points that we can follow. For numeric data, we would want to use histograms, correlation plots, and pivot tables. For categorical data, we want to use bar charts and pivot tables. Just to give a brief of what categorical and numerical data is. This one, give me 1 second. Sorry, excuse me. So the categorical data is values that classify the samples into sets of similar samples. And for the numerical data, these are values that change from sample to sample, and they are different types of values, discrete, continuous, or time-based. As we explore the data, we'll be able to see what kind of numerical or categorical values they are. Some categorical data in the Titanic were survived, sex, and embarked. And numerical would be age, fare, sibling, and or spouse, and patch. This code snippet here will be displaying the distributions of all the numeric values. When we run this cell, there'll be an error because we need to run the cells above it. So this cell separates all the numeric value columns into a variable called numerical columns. And this one separates all the categorical columns into a variable called categorical column. Now, when we run it again, it'll display a nice list of histograms of the age, the distribution of the age. As you can see, most people would have been between the ages of 20 and 31, 32. The next one will be siblings or spouse. This would be the amount of siblings or spouses is between 0 and 1. This seems to be the most. In the patch and the fare, which is the price of the ticket. And next, the next cell will be the distribution of numerical data using heat maps. So there are two different ways we can view it. We can use numerical columns dot correlation, which will display it in a tabular format like this with the values. Or we can use seaborn dot heat map to display it in a graphical way. Everybody up to here, lost? No questions, everybody good? All right.
Okay, Faith is asking, can you go over how to access files in the drive from the Collab notebooks?
Sure, no problem. So when you're on the Collab notebook itself, around the top left side of the screen, there are these icons here. You click this folder, which is called Files. When we click it, it should, if it's not already open, it should open up this menu here. And at the top of here, there are these options for upload, refresh, unmount drive, or if it's not mounted, connect the drive, and then show hidden files. So if on your screen it doesn't have the lines through the folder, that means you need to click on it, and it will ask you for permissions to connect to Google Drive. Let me know if you have done that, please.
Anyone else? Any other questions? That was a good question there, Faith. So I'm glad you were able to go over that, Nicholas. So I think you could proceed from here.
Yeah, just let me know, Faith, in the chat if you need me to go through again. So I'll be moving on to the distribution of the categorical data. Okay, got through, good. That's awesome. In the distribution of the categorical data, this is a code snippet that I have of that will display the graphs for the categorical data. I wouldn't say it's too difficult to understand the code snippet, but here we are taking the categorical columns that we created, hold on, above here. And we are putting that inside the seaborn bar plot. And we're just iterating through a for loop so we're able to print it out one after the other quickly. And then at the end here, we're setting it to column name. So survive. If I change this, hello, and we run it again, it will change here. So this part here is setting the title, and we want to use the column name. So when you have it on your own, you could play around with the code to see how it interfaces with what is displayed on the screen. And here we can see some bar plots for survive, P class, passenger class 1, 2, 3. the sex, male, female. And as you can see here, most male died. Well, there's a lot of males, sorry. The ticket, this is starting to look quite messy. Cabin as well, this is starting to look quite messy. And then embarked, you can see S, C, and Q. Now, some of these values can be found on the overview on Kaggle, where they would give you a description of the different features of the data sets from here. And because of how messy cabin and ticket is getting in the graph, we would want to start doing some data cleaning on those specific features. So this would be a way to get an understanding of what features we would want to do some data cleaning on to get a better visualization of. Now here's a cool snippet of comparing survival to each of these categorical variables. So when we run this code cell, we can see that survive 0 or 1, and the P class 1, 2, and 3. So within the passenger class 1, there were a lot of people that survived. A lot, I still say a lot, but quite less than the people that survived did not survive. With regards to the survival of male or females, you can see a lot of males didn't survive, and quite a few of the females did not survive. Can be getting quite dark, yes. And then on the embarked and the survived, people who came onto the Titanic at the location C, Q, and F, you can see the relationship between being survived and where they came on from. Now, visualizing the distribution of data in the data set using histograms. This is another way of showing the histogram. A simple one-line code instead of having to have that multi-line code. But just this way, it doesn't look too readable. But it's a quick glance to get an understanding of the distribution of the data. And next we'll be handling null values. So in the presentation, we saw that from the heat map, there were a lot of null values in age and cabin, and also some embark. And this is a quick snippet of the pivot table from pandas, if you want to use the pivot table inside the code. And here we'll be doing data imputation of the embarked column. So after we run this cell, we will see that there are 2 rows that has missing values for embarked, where they have NaN. And we will have a graph to visualize and guess where they embarked from. So here we'll be using a box plot. But before we look at the box plot, we can look back at the 2 rows here. We can see that the fare is 80 for both of them. And then they are P class 1, passenger class 1. So on the box plot, we can see the legend here. P class, the blue is 1, orange is 2, green is 3. So we'll be looking at the blue box plot here, which is this one and this one, and also something here, but can't really see it properly. And then we were looking for an average or mean of $80 fare, which is in this area here. So we can see here, this looks like 50 or 40. This is the average on the box plot, this line here. But on this box plot, we can see average looks a little closer to be 80. So we can make a guess that these 2 passengers came from C, location C. So now to add the values, we'll be adding values to those columns, displaying the heat map before data imputation. This will be for the age we're moving on to the ages. So replacing the null values for the age column with the mean value of the passenger age in the data set. When we run this cell, we will be able to fill all the empty values with the mean of the ages inside the data set itself. And now when we run this run this code, you'll see there's a difference from the ages here and the ages here. And that will bring us to the end. What we can do for the embarked, a quick here. This cell right below, we can do this and just copy and paste here. And we want to access embarked. And we will change this to the value C. And when we do that, and we run this code cell below here, you can see it's empty because we replace these NaN with the value C. So those are two ways of filling in the values for embarked and age. And that'll be the end of this tutorial presentation. Hopefully we have enough time. If not, you can follow these steps with the climate change data set that they have on the WiDS Datathon 2023. It's already the same process of downloading these files, adding it to Google Drive, and setting up your own EDA in your notebook. Any questions, clarifications? Everybody good? Anybody lost?
Anisha is asking, is EDA only performed on the trained data set only?
It is mostly performed on the trained data set, but you can also do it on the test data set to get an understanding of what they're going to test and what features were missing from the train and test data sets. But our focus will on the training data set because we're going to use the machine learning model to learn from the training data set. And then it will use the test data set, which will be unseen data, so we can get an accuracy of how good the model was trained. Okay, no problem.
That's
All
a
right.
good question.
I'll be moving it on to handing back over to Shannon Ray so she can introduce the next section for you guys.
One last thing, sorry to interrupt before I continue. Is a real good question she asked there, and it does bring about something. If she's interested, you can look into something called data drift, and you might see why in some cases, not just the train might need to be explored, and you might want to also see a test if you're interested.
Thanks for that, Shankar. And in fact, there is a tutorial on data drift as well. So at the end of the session today, we will point you all back to the tutorial resources on the WiDS, the 2023 Datathon website, and you could actually access that. It may be a little more intermediate, but all of you can access it and see what's involved there. So at this point, yes, let me hand you back to Shannon Ray, and she'll take you on to the next segment.
Okay, so next we're gonna look at machine learning techniques. So I have a video for you guys done by one of the other mentors, which will cover this topic. Well, two videos.
Good morning, everyone.
Are you guys hearing?
Yes, we are. That's the highest, the max volume?
Yeah.
Yes.
My name is Mercedes Kwame, and today I'll be giving an introduction to machine learning techniques. So Shannon Ray would have already presented a bit on the types of machine learning. For this section, I will focus on supervised learning. So supervised learning uses labeled datasets to train algorithms to either classify data or to predict outcomes. And the prediction accuracy of the algorithm is then assessed using a test dataset. So this would be data that the algorithm has never, quote unquote, seen before. Technically it's new data to the algorithm. These types of problems could be subdivided into two categories, namely classification problems and regression problems. So classification problems are those where the target variable is categorical. So an example would be predicting whether a student either passed or failed an exam, and this would be a binary classification since there's only two outcomes. Some classification algorithms include logistic regression, which can only be used for binary classification, like the example above. There's also naive Bayes, support vector machines, k-nearest neighbors, decision trees, and random forest classifiers. There are other ones, but these are some of the most popular. Regression problems, on the other hand, are those where the target variable is continuous. So an example would be predicting a student's actual score on an exam. Some regression algorithms include linear regression, which would be the one that we're focusing on today. But there's also decision tree regression, support vector regression, and random forest regressor, among others. So one important thing to note is that there is some overlap. So the two types of algorithms can actually be used for similar problems. It just depends on how you frame your problem. So an example of a regression problem would be, what is the temperature going to be tomorrow? So here you're trying to predict the exact temperature. Whereas a classification problem would be, would it be hot or cold tomorrow? Where you have some threshold that's categorized as hot and some threshold that's categorized as cold. So as I said earlier, today we'll be focusing on linear regression. So what is linear regression? Well, in simple terms, regression models are used to predict an independent variable based on predictor variables. So some types of regression models include simple linear regression and multiple linear regression. There are other types of regression models like polynomial and others, but today we'll focus just on linear regression. So linear regression is used when we want to predict a continuous independent variable given some predictor variables. So simple linear regression includes just one dependent variable and one independent variable. An example of this would be predicting body weight using height. Multiple linear regression, on the other hand, includes one dependent variable and two or more independent variables. So an example would be predicting body weight again, but this time using height, age, and hours of exercise per week. So now we'll look at the mathematical model for the simple linear regression. So the simple linear regression model is defined as you see below, and here y represents the dependent variable, x represents the independent variable, beta sub 0 represents the intercept, beta sub 1 represents the slope, and epsilon represents the random error in the model. So the multiple linear regression model is pretty similar. The only real difference is that you will see we now have multiple betas and x's. And here, x1 to xn represent the n number of independent variables. Next, we look at a graph of a linear regression model. And this is just a nice little sketch that gives some useful information. So you'll see that the dependent variable is represented on the y-axis. And this, of course, is the variable that we want to explain. Next, the independent variable is represented on the x-axis. And these are your predictor variables, or the factors that we think are influencing the dependent variable. So next you have your regression line, or the line of best fit, and this essentially is the line that minimizes the difference between the line and all of the data points in total, the total distance. And of course you have your data points. So where the line of best fit cuts the y-axis, that's the intercept, or your beta 0. Next, you have the slope of the regression line, which tells you the relationship between y and x. So essentially, when x increases or decreases, how much does y increase or decrease? So you'll see most of your data points fall within this 95% confidence band. Basically, if a data point falls outside of these lines, you are 95% sure that something is off about it, and that would be considered an outlier, which are the extreme points in your data. For regression especially, it tends to be sensitive to outliers, so you would want to remove these when you're doing your data cleaning, unless there's some reason that there might be outliers in the data. So it is a little bit subjective, but for the most part, you would want to remove outliers. So we'll wrap up the introduction portion with some pros and cons of the linear regression algorithm. So some of the pros is that it's fairly easy to implement, so you're not required to tune parameters and that kind of thing. It also has a really short runtime. It's highly interpretable and is the basis for many other methods. Some of the cons are that it is really sensitive to noise and to outliers. It is also prone to overfitting, and it assumes a linear relationship between the predictor variables and the target variable. So now we'll move into a Google Colab notebook where we'll actually implement a linear regression algorithm.
Okay, so before we go on to the second video, Rihanna, could you share the notebook in the chat? Okay, great. So you guys can go ahead and open up the notebook. While I get the second video ready.
No, I think Rihanna, this is not the notebook. It's the other link. This is a tutorial on linear regression, but this is a really great resource. So for persons who want to go further into the actual linear regression in Python, you all can use this resource. And also, I just wanted to make a note as well that I know some of you may use R and other languages as well. Remember, the techniques would be the same, it's just the code would be a little bit different. I know some of you would also probably use SPSS and all these things. Just note that you also have the mechanism of being able to integrate Python code and R into SPSS and other programs. MATLAB is also a great one. For those of you who probably engineering or math and stats, you may use MATLAB. So just letting you know. So let's just give you 1 second. Rihanna will send the notebook and then we'll proceed.
Okay, I have it. I have it there. Oh, please. Okay, you guys let me know when you have the notebook open and ready, and I'll start the video.
Is everyone able to access? Okay, let us know in the chat.
Okay.
Yeah, great.
So now we'll move into the linear regression example where we'll actually run the algorithm. So you could open the notebook and scroll down to this section which says linear regression machine learning example. So as a first step here, we'll load the libraries that we need. So you could go ahead and run that block of code. So we're importing pandas, numpy, matplotlib, seaborn, and sklearn. Sklearn is the library that has a lot of the machine learning algorithms. We'll also be importing data sets from sklearn. So you could go ahead and run that second bit of code. So next we'll load the data set from the sklearn library. So we're loading the data set diabetes, and we're also checking the type. So we see that the data type. So we see that it has loaded as an sklearn bunch object. Essentially, the data type that we want to be working with is a data frame, so we will change this later down the line. Next, we will print the description of the data set that we're using to have a better understanding of the variables. So like I said, this is the diabetes data set, and it's a toy data set, meaning it's not real data. And here we have the description, right? So there's 10 baseline variables: age, sex, body mass index, average blood pressure, and also 6 blood serum measurements labeled S1 through S6. And then we have the target variable, which is a quantitative measure of the disease progression 1 year after baseline. So of course the disease here being diabetes. So like I said, we want to work with a data frame instead of a bunch object. So we're going to go ahead and define a data frame using data from the data set that we loaded. So you can run this first bit of code. This will just load the predictor variables, and the second bit of code will append the target variable onto our data frame. We'll also print the first 5 rows of our data just to make sure that everything looks okay. So it looks okay. We have the 10 variables and we have our target variable, and all the values look okay. So next we'll move into data preparation. And I know you would have covered this in the section before, but I've included a little bit of it here just so you can have an appreciation for the workflow of how things would run when you're actually running a machine learning algorithm when you're doing this type of problem. So we'll first check for missing values. We'll run this code, go ahead and run it. So you can see that we have zeros across the board, which means we have no missing values in our data set. And like I mentioned before, this is a toy data set, so it was generated. It's not real world data. So it is.
Okay, I'm just going to pause the video. I know we had a little bit of audio issues because the speaker's recording was a bit low. Is everyone able to hear it clearly enough on your end? Can you all let us know in the chat? So far, you can hear? Okay, great. I just wanted to let you all know that so far, she's just giving you all a rundown. It's low, but hearing. Excellent. Thank you all. Really apologize for that. So really and truly, the steps here are a bit similar to what Nicholas showed you all in the last segment. So you could be maybe able to run through it a bit faster. But if you'll have any issues, do let us know so we can continue.
Is very clean and it has no missing. That means we have no missing values in our data set. And like I mentioned before, this is a toy data set, so it was generated. It's not real world data, so it is very clean and it has no missing values. For a real world problem, it would require a lot more cleaning, and this would probably be a lot more intense and take up a lot more of your time. But that's not within the scope of this tutorial. Again, you would have covered this already, but just for an appreciation of the workflow, we will do some basic exploratory data analysis. So first, we'll take a look at the distribution of the target variable. You could go ahead and run that code. It's taking a little while to run. Here it is. Okay, so you can see here when you look at the graph, it doesn't appear to be perfectly bell-shaped. It's actually a little bit skewed. So not what we would love to see, but we'll move on. We'll move on and check the linear correlations between the variables. So an important requirement of the linear regression, and I mentioned this before, is that there needs to be a linear relationship between the predictor variables and the target variables. And the stronger the linear correlation, the better your model will perform. So we'll now visualize the correlations in a heat map. So what a heat map does is it uses color scales to represent the strength and direction of the correlations. So the darkest colors here represents strong negative correlation, and the lightest colors represent strong positive correlation. So you go ahead and run this bit of code. And we can see our heat map here, right? So you'll notice that there's ones all down the diagonal, and that's because that's the correlation of the variable with itself, right? So age here and age, the correlation is 1. We would expect it to be perfectly correlated with itself, right? Next, we can look at the correlations of the predictors with the target variable. So we'll look at this last row. And we can see that, for instance, BMI has what I would call a fairly high correlation with the target. It has a correlation of 0.59. So that's a strongish positive correlation. There's also a relatively strong positive correlation with S5 and the target variable. So yeah, they're okay. We're seeing some okay correlations. So moving on to feature selection. Feature selection is the process of identifying and selecting a subset of input variables that are most relevant to the target variable. And this is important. In this case, we only have 10 predictors, so it's not that important. But when you're working with big data sets, you tend to have a lot of variables, and it's important for just reducing the number of variables in your model, and also for reducing redundancy. So some variables might be measuring essentially the same things. So one basic method to do this for regression problems is by using the strength of the variable's correlation with the target variable. And we use this as a selection criteria. So for example, here we will select the variables that have a correlation higher than 0.5. So this bit of code, I'm just defining the threshold and identifying and printing out those variables that have a high correlation, or a correlation higher than 0.5, right? So again, in this case, it's just 2 variables, so not completely necessary, but this would be helpful if you have a very large number of variables. So the next step would be to define the X variable for our regression, or the X variables, as a data frame consisting only of the selected features. And then we'd also define Y as the target variable. So you go ahead and run that code. The next step is to split the dataset into training and test data. So I would have mentioned before that for supervised learning, we train the model using a training dataset, and then we test the model using a test dataset, which is data that the model has never seen before, or new data. And the training dataset is usually labeled so that the model can learn the relationship between the predictors and the target variable, whereas with the test dataset, we feed the model the predictor variables and allow it to predict what the target variable would be. And then we compare the predicted variables, the predicted values that the model predicted against the actual values for that test dataset, and we see how accurate our model is. So just a note, the test size argument allows us to specify what portion of the data we want to use as the test dataset. So here we have indicated that 30% of our data will be used as testing, so therefore 70% of the data will be used to train the model. And a note, by default, this split is done randomly every time we run this code. So here I'm using the argument random state equals 42 to ensure that we get the same training and test dataset every time I run this code. And that just helps when you're rerunning the experiment, you get the same results. And for this, any positive integer or 0 can be used for this random state, right? So go ahead and run this code. And we also printed the shape of the training dataset and the test dataset. So you can see the training data, there's 309 rows on 2 variables. Those are the 2 predictor variables, and 133 rows on 2 variables for the test set. So now we move on to training the model, testing the model, and evaluating the model. So we'll run this block of code. This first line here is just defining the linear regressor, and then we're fitting it to our data with the second line of code. And then we print out the model evaluation metrics. So the performance on the training dataset, the RMSE, and I'll explain this later on. The RMSE value was 58.4, and the R-squared value was 0.4 on the training dataset. On the test dataset, which would have been the new data that the model hadn't seen before, the performance was, the RMSE was 52.9, and the R-squared score was 0.48. Skip past this block of code because I forgot to take that out. We move on to model evaluation. So we're interpreting these 2 values here, right? So the R-squared value, which for our model was 0.48. Okay, this is the coefficient of determination, and it essentially tells us what portion of the variation in the target variable is explained by our model. So in this case, it's 0.48. So this means that variation in our predictor variables accounted for 48.1% of the variation in the target variable. So that's not too bad. Next, we move on to interpret the RMSE. So this is the root mean square error, and it measures the average difference between the values predicted by the model and the actual values in the test dataset. So the lower this value, the better. In this case, our RMSE is 52.9, which is quite high. So this suggests that our model does not do a good job at predicting the target variable. To improve this metric, we could take a couple different steps. One possible step would be to adjust the selected features and run the model again and evaluate it again to see if there's any improvement. So that brings us to the end of this tutorial. I've included a useful resource if you want to get deeper into the different machine learning algorithms. You can check out that link. And thank you for your attention, and best of luck in the competition. Bye.
Okay, great. So we would really like to thank Mercedes. She was unable to join us today, and really, we're really very grateful for her to record her segment. I know that was a lot of information packed into that little segment there, but do you all have any questions? I expect that some persons may need to get accustomed to the jargon, the testing, the training, the validation of the models, etc. Thank you, Stephen. Yes, I'm hoping that it was very informative. You all will get the recordings. You'll be able to play it back and slow it down a little bit for certain portions that you would need to do to run for that example. We really wanted to showcase one of the most popular modeling involved in statistics. I would always say it's one of the basis or background models for a lot of any of these statistical types of not only tests, but also just the general building from the ground up of prediction. And that is regression and linear regression itself. I mean, that's just one of many different types of regression. You have logistic, you have polynomial, etc. But this is really one of the building blocks. A lot of you may have heard of it or know how it works. I mean, Mercedes gave a really, really concise overview of what it is in a mathematical sense, in terms of the different variables, the independent and dependent variables, and how they interplay with each other. And then, of course, we wanted to showcase a bit of a different example to show you how it works with respect to diabetes. If you would like to do more in terms of like a diabetes type or a medical type of aspect using that sort of prediction model, the 2021 Datathon was actually based on a diabetes challenge with respect to that sort of data. So we wanted to give you all different types of examples before we actually kind of proceed into the actual challenge itself, which would be the open session next week, where we would give you all some time between now and next week to kind of think about it, go into the materials and the examples and see where, you know, if you need some more understanding, if you can use the notebooks, and also gain some more insights into how to actually use these tools to complement what will come into the challenge in terms of the types of things we would have to do. Just to bear in mind before we go on to Shankar's segment, because he will follow on from what Mercedes said. I know everybody might be thinking it looks a little intense to some of you in terms of the beginners, but just know that when we do form teams, different people will have different tasks on the team. So not everybody will be doing machine learning, not everybody will be doing prediction. It will really come into different, you know, you'll have different tasks based on your skill sets. If some of you may be able to research more than others, we will put you all to do that. If some of you have advanced training and you want to build different types of machine learning models in addition to the regression model, we can also have you do that as well. So between now and next Saturday, we will have you just kind of integrate this knowledge into the climate data set and sort of get a kind of a feel for just, I always like to say, to play around with the data, to use the tools, and to actually see how you feel in terms of your confidence level with working with data sets. So I'm going to pass you on to Shannon Ray now. Oh, sorry, I see there's a question before we go back to Shankar. Why was 52 a not so good RMSE value? What range would be considered a good value in the diabetes data set? So that is a good question, Anisha. In fact, when we're looking at not only the root mean square errors, but generally some of these metrics in terms of like correlation, coefficients, R-squared values, the coefficient of determination, etc. There are different ranges based on the fact that these metrics are sort of like, if you want to think about them, a probability value. So say between 0 and 1, if you want to think of the values, like for instance, the correlation values, the higher the correlation values, the closer they are to 1 would mean a better fit. In terms of the RMSE, in terms of the scoring that she had there, 52, or you could probably think of that as 52%, that would have fallen a bit to like about 0.5 or so. So it would be probably a little bit midway in terms of, you would say the fit is fair, but it could be a little bit better in terms of how well the data, the predicted values fit the model. Because remember, we actually doing prediction here, and we're training these data sets to actually tell us if it will follow a similar trend to what will happen in real life based on what happened in the past. So you actually want to have a metric that could tell you, is this model fitting well with the data or not? So in terms of the diabetes data, is really, I think what she meant to say was really, in general, the metric has to go, it has a specific range, and the metric that you use, especially with respect to these climate data, will be an indicator of how well the data fits. So when you actually get into the climate challenge and you start to see some of these values come up, you'll be able to understand better how to navigate and improve your models to be able to get a better fit, as we call it. I'm hoping that answers the question. And I think that you all are asking some excellent questions. So we'll also provide some more resources, right? Shankar actually provided some great resources here for the interested reader on regression. He said there are fancy ML models, and he is going to come in now and give you all an overview in terms a little bit more on the metrics. So Shankar, you'll clear that up a little bit more for the rest of us. I'll pass it over to you.
All right, thank you, Dr. Addison. So the stuff I send in chat, what that really is the PDF is your second link, I believe. And if this doesn't work, you could just search regression and other stories. And it's a free web book. And it's one of the best resources I've found so far that explains regression from a basic understanding into what it really is. And then goes into some of the specialized models in regression. And it is a real good first pass because even, I think it was last year, some of the same in WiDS, some of the best performing models were regression models, and it's not as simple as just fitting a straight line. It gets a little bit more complicated, but in stages you could get a good understanding, and you can kind of just use that as a resource from now and the rest of your career. You don't have to try and understand it all at once. If you have a certain problem, you can always make reference to probability regression as a first pass, which is why I sent it there, and it's openly available. Now respect to
one more thing before Shankar proceeds. I know we're on time in terms of 12:30, but we usually have a little bit of extra time. So for those of you who would like to stay back at least 10 to 15 minutes so he can go through his segment, feel free to do so. So Shankar, you could proceed.
Yeah, something I was going to say. With respect to why 52 was a good RMSE, in the presentation I'm going to do now, you might be able to get a better understanding of it quantitatively. If I could just share the screen. All right, great. If I can't get through sharing, I'll just have Sean.
We are seeing your screen, yes.
Okay, great. Let's minimize. Lovely. So you all see the top of the book?
Yes.
Okay, so as my colleague Mercedes would have spoken, she would have given you all a brief introduction as to what linear regression is, and I believe she would have done it on Google Colab. This is Deepnote. It's a platform that they would have introduced to us recently at the launch of WiDS, and the reason they pushed it so hard is it's a bit easier than Colab in the sense of it gets you exploring data quicker. So for example, right, as Nicholas and Mercedes would have done, they would have, when you load the data, right, let's try this out here. Let's load the data in. Start machine first.
In the meantime, just to mention, Shankar, this is some of the climate data set, correct? Is it going to do
Yes,
the
it
example?
is.
Okay, great. So this is actually from the challenge we're going to show you all.
Okay, great. So as you see, the first thing that all we did was we imported the pandas library, which is used for handling any kind of large data, and the sklearn library's linear regression model, and then we load the data. Well, for the tutorial, I think this is actually not the full data set, but a reduced version of the data set, just for the sake of pedagogy.
Yes.
So as you can see at a first glance, compared to Colab, you could see all your variables are a bit easier. You could actually drop down things and sort them, filter, and for any kind of for just my colleagues who did exploratory data analysis, they will tell you that it is hell when it's code to do some of these things sometimes, and it's a bit cumbersome. Deepnote actually provides a much easier interface to sort and filter and do all that jazz. And it's so good, you can actually just click on visualize, and instead of having to write code using low-level libraries like matplotlib or even things like plotly, you can just click on the visualize as I just did there. Click on any kind of chart you want to use. Most of the time is a bar chart or a line chart. So let's do a line chart. Click on a x-axis. So let me try using the let's try putting latitude on the x-axis, and on the Yes, ignore that noise is the window, window frame tearing off new walls, low rent, and let's put that
In the
break.
meantime, Shankar, sorry to interrupt. Are you all able to access the notebook? I don't know if I asked you all. Are you all able to access? So you could follow along with him. Let us know.
And color. If we just click on play, it should plot the graph.
Great. Thanks, Stephen. Yes. Okay, so Shankar, just go back a little bit so that I think some of them might have to catch up. So let's see from the line chart again. How did you access it?
Okay, that's not 1 second, right?
Yes.
So the first thing you do is you load your data. You have your columns here, and then at the top of the data frame widget, you should see a button saying visualize, right? And if you click on visualize, it should allow you to choose what type of chart you want to do, the parameters for each, the X and Y axis, and some chart options here, like color and size of the points or whatever the case may be. And in this case, what you need also need to pay attention to is the data type. You can actually change the data type here. So, for example, one thing that is really annoying is whenever you have data in, oh dear Lord, I have two windows. Oh, that's because I clicked visualize twice. Oh no, hold on. Anisha, I didn't realize this, but apparently when if a student is trying to follow along, it's interactive.
Oh, it's everybody is actually okay. That is interesting. Okay, so they were supposed to copy the space. That's
actually,
probably
we could just stop our advantage. So Anisha,
okay, yes,
let's move on
Anisha.
interactive.
Yes, Anisha is clicking on it at the same time. That's great. Let's see how that works.
No, that's how I actually teach to Anisha. So Anisha, click on type. The Wi-Fi is not it today, boy.
She said, sorry, no, Anisha, go ahead. Because we actually now recognize that you all could interact with it one time. So
it's maybe easier to kind of get all the hands on a bit of experience with it. So Anisha, let's change the type to a line graph, please. Nice. And choose two columns. Choose an X and a Y. And actually, no, for the X, choose start date. Okay, great. So, and I'll choose a Y column. Let's look at the temperature actually, because that's what we're trying to predict. We're trying to predict temperature, 2 meters. Right. One thing you'll notice here, right, is these two little small boxes next to the variable. One is a drop. Oh, come on, Digicel.
in the meantime, this is actually called the no code option in Deepnote. Deepnote is a similar notebook to Google Colab, so that you, for persons who don't really like to see the code, you could point and click like Anisha is doing and build the graphs. But the code is on the back end of whatever this interface is here that we're looking at, that we're seeing. We could actually do a point and click. So it's really a nice tool to have at your disposal. So you could actually see that it looks similar to what I would say. I know most of you like Excel, Microsoft Excel, and pointing and clicking on the graphs based on the data. So that actually gives you a similar functionality.
Okay, so one thing we can see here is we have the option to actually format the column into two instead of using code to change it.
We lost Shankar. Are you all hearing? Or is it just my end?
Yeah,
we
looks
lost
like we lost them.
Okay. In the meantime, Loria, yes, you can pull the code. However, I must let you all know, and I believe Shankar was going to let you all know, that this Deepnote, for the purposes of the Datathon, it's accessible, but it really usually has a paywall, which means that you would have to pay a certain fee, like monthly or yearly, to use it, because it has an automated ML automated machine learning feature, in that there are some aspects where you could build it not having to do the code yourself, and you would have be able to build nodes. For those of you who use things like Microsoft Azure and all these things, Deepnote will allow you to do that as well. But in terms of the code, yeah, you should be able to pull the code from the no code option. I don't know right now if this current version, it gives you it in a free sense. I know Shankar got bumped off a bit. In the
Yeah.
meantime, yes, are you back,
Hi.
Shankar?
Yeah, you hear me?
Yes, we're hearing you now.
Okay,
I know it's
Sean,
today
could
some
you please-
internet problems.
Yeah, Sean, could you please share your notebook? I'll just do it through your window. 'Cause I think my system is pretty weak and I
Shannon
can't.
Ray here. Let's see if we can.
Yes, I'm still here, so I'm
Yes.
sure.
Okay, great.
Yeah. We really need to update this system. Okay, so why is the window minimized? What?
Okay, so we have, yes, we're seeing some of the plots.
Okay, so
It's a little blurry.
Okay, do you
Yeah.
want to share instead? It might be because I have so many things open.
I'm gonna see how many same issues as you.
Let me see if I can go ahead.
It's
Nicholas?
looking clean for me.
It looking
not
clean.
blurry.
It looked clean just now, yeah.
Okay.
We'll try it. Right, it looks great here.
Okay, great. So let's scroll to the top. Lovely. And let's just import the data, run the first cell. No, oh boy.
Wow, I didn't.
Okay.
It's okay. It's okay. Don't worry. These things happen. So it's okay. It's just a little technical difficulty. In the meantime, we will ask you all to run it on the back end, a few of you, and we will see how we can proceed from here. But what
Yeah.
I will let you all know, this is actually one of the tutorials on the Datathon website. So Shankar was going to show you all an actual snippet of it to kind of give you a guidance based on what Mercedes spoke of. Yeah, go ahead. Shankar.
What I have here will be an edited version of what is actually up. The
Yes.
link should be in the drive because the actual one from WiDS, they have a lot of clutter and a bunch of stuff around them for us. And I actually explained what the metrics mean a little bit more in this and would have been able to better shed some light on the last question, ask about the RMSE score. Shannon, can you just stop sharing? Let me try and reshare for myself and see if it works. Thank you. Okay. Fingers crossed. Close every single thing I'm not using right now. Close that. Close that. Low code option to plot the graph, and you can actually modify the data types here in these two boxes next to the variable, as well as whether you want change data for some, or you can actually do something with the column. You can do a sum, a moving average, max, min, count, bin. You can modify data using summary functions and aggregation methods right next to the variable to make your life easier. And you can do a lot of things here. I'll leave it up to you all to play around with this and see what y'all can do with the visualizations. This here is just some basic processing. So this doesn't really have anything to do with the discussion of metrics. So I'll just run this quickly. Lovely. So R squared. The R squared metric, all this does here is it's an explanation about what it is a little bit deeper compared to what Mercedes did. The formula for it is this, where y hat I is the prediction, y sub I is the true value, and the bar means the mean. Now, it does look like a lot of math. Don't let that scare you, because let's look at the graph here. All we're doing is we are trying to see what percentage of the data can be explained through the variables we have. So what does that really mean to say? Okay, it means to say if we have, let's say, n features, right? We have n columns, or better, let's use numbers. Let's say I have 4 columns in total, and you're trying to predict, let's say, the 4th column, and you're using 3 variables to predict the 4th column. And you have a R squared score of, let's say, 90, then that means 90% of the values in the 4th column, or I should say, outcomes, can be explained using those 3 variables. Now, RMSE is a little bit different. What RMSE does is it kind of it assists in giving you a tangible representation of how much it's off by. So if you have, let's say, a graph here, right? Like this graph here, consider the blue points and this the best fit line being the dotted line in the middle, right? This slanted line here. What the RMSE attempts to do is it gives some context to what you would have seen in the R squared score. Instead of giving you a representation of how much of the data your model could accurately represent, it quantifies how much the model is off by. So what what per se is the error between your predictions and your the value you give. Now the reason there is no fixed number, no fixed good RMSE number, is it will vary as your data is scaled, which is why you normalize and standardize. But to make things simple, consider you have, let's say, an RMSE score of 4, and you're trying to predict sales for something, right? Sales for the quarter, or in this case here, the temperature. If your RMSE is like, let's say, 2 degrees off, right? You have an RMSE score of 2. That means the mean square error of your values is like probably 2 degrees off from the actual thing. What that really means is, okay, well, that's a low variation. But depending now, let's say you're a stockbroker and you're trying to analyze the financial markets, and your value is 1,000. You have 2 models. One has an RMSE score of, let's say, $1,000, and another have an RMSE score of, let's say, $1 million. Obviously, the one at $1 million is much worse. You would want to get very low RMSE scores, but there is no fixed good value. The RMSE, a good RMSE, is based on the context at hand. It's based on the range of your values. If your values are very large, you have a very large RMSE, but it's not that far off from the context, or not that large out of context, it's a good score. So that's why data science is more of an art than an exact science, to be honest, sometimes. And these are just general guidelines. And whether your RMSE score is good or bad, it will really depend on the problem you're trying to solve. And what you can do to get a representation of it is this here. So the WiDS Datathon, this will be there for them. What you can see here is you can see that the model here does actually look very linear. So based on our R-squared score, which was, I believe, this was 94, let's say 95%. We had a very low RMSE score as well. I think it was like, I think 4 something, which is very good. We can clearly show that when we visualize the data, it supports that, because it does have a strong linear trend, and the months do follow up in a linear fashion. And that kind of gives an idea of, well, okay, it shows how the R-squared and RMSE can be used to tell you different things about the model. Where, simply put, and I think I had it in the last line here, I'm not sure somewhere. The RMSE tells us how well a regression model can predict the value of a response in absolute terms, or the units of the value, whereas R-squared tells us how well the model can predict the value of the response variable in percentage. One gives you a holistic representation of a holistic idea of how well the model can represent the output. One gives you costs, I should say, as how bad the model is at predicting it in terms of the units you're trying to predict. I hope that answers your question, Nisha.
Shankar, that is a really, really comprehensive explanation. So we're really happy to have that basis. And this is actually, the RMSE is really the metric. There are a few of them, but that's the one that is going to be used in the climate challenge, really, to score your models in terms of when we upload your predicted data sets to the system when we come to that point. So we'll discuss all of those aspects in the open session. Shankar, you wanted to continue. Is there anything else we need to show them?
Last thing,
yes.
This is an example here. Look, if you can see the RMSE for this model is actually pretty low. It's like, what, 3? And that shows that our model is a good estimator, maybe a bit too good. You want to be careful that your RMSE isn't too good, like 0 point something, else that could lead to overfitting. And you don't want to make sure that's too bad, like 300, because that is underfitting, and you need to. Well, that's for the next week, probably sometime. The rest of this notebook here is for the interested reader. Y'all can actually look and see what WiDS did, like how they compare the R-squared score of the train and test. As you can see here, we have some drift, because this is actually a big gap here. And in the original notebook, they go into random forest and, well, cross-validation and all that. If you're interested, you can go towards it. But please do not be daunted. Start from the top and try to understand and appreciate how useful R-squared and RMSE is for training and test. And only then I would recommend go on to things like cross-validation and all that fancy jazz.
Great.
Thank you.
Thank you very much, Shankar. That was very, very concise and comprehensive. And before you all go, I know we are a little past our original time. This was really into our question time. I just wanted to share the screen to give you all a kind of a overview of how we move on from this point into the next session in terms of it's a more relaxed session, it's a more open session. So the last 2 tutorials that we did, we really tried to compact the information into a basic overview. I think someone's mic is on. And then here now, what we really wanted to do, we incorporated some of these tutorials and resources. That's the page I just sent to you all. So you could actually see here, we would have gone through the Kaggle competitions tutorial, the building regression model. There is one on the data set from last year. This is actually the one I participated in terms of the prediction for the energy consumption of buildings. Have a look at that since you looked at the regression here. It's really nice to see the context of regression, not only for the climate challenge, but also in different ways, like the diabetes data set and even the prediction of energy consumption in buildings and whatnot. There are a few other resources on Python for those of you who are interested in going further into Python. I know some of you may want to use R, but if you would like to stick with the Python and learn how to use Python for this purpose, feel free. And then this is a Deepnote tutorial that we were trying to access. We had a little technical difficulty because Shankar tried to modify the tutorial to kind of shorten it for your purposes. But everything that you would have seen there is in here for your purposes, and it's actually based on a subset of the climate data. So for those of you who would like to continue, we would recommend that you go through the Deepnote tutorial, the intro, the introduction, the beginner, and also the intermediate. You can try with those. Run the codes, look at the codes and see what's happening. We had some really good questions about the RMSE score and all of these different metrics. So I know that it's kind of building towards where we will be when we form our teams and actually are kind of honing on different parts of the modeling process. For those of you who would like more information about the challenge, the data set, the actual variables themselves. I know we had mentioned this in the first tutorial on our information session, but feel free to click on the same resource I sent. And in terms of the overview and the data, you can go here. Remember, you have to have a Kaggle username, and you can go here and access the actual data description, and you can scroll down, see all the variables involved. And I would advise you, if you don't know some of the meanings, you can actually research them. We would like to have some of you on the teams to actually help us research some of the variables further, because when we do the EDA and we look at it in terms of what Nicholas had said to you all initially, if we have missing values, we need to determine how to deal with the missing values. We can't just put in any values that we want. We have to understand the variables, and that's a huge part of the process. So you could also have a look. Remember when he did the Titanic data set, he had shown you how to download and everything. Feel free to do so and use the same steps that he had provided. You can download the same the data set and actually use the collab. You may have to change some of the variable names, etc. But that's why I wanted you all to look at the Deepnote tutorial, which actually has the data set lodged there. And we can go further into actually talking about it now in a context of how do we predict from this and how do we actually improve it. What you will notice is, just from my experience being on a team, is that initially you're going to have a lot of EDA happening. It's going to take up the majority of the time with the exploratory part of it. And then after a while, all you will be doing after you first predict is going to improve the prediction. You're going to have a few different models, and our mentors will be the ones to kind of showcase to you all how to do the modeling aspect for those of you who are more beginners. So you don't have to feel fear about that part of it. We're not going to throw everything on you. It's going to be everyone helping each other in this type of collaborative community. So at this point, this is really the point we're at in terms of the direction we're heading in. And we invite those of you who would like to continue the journey. Even those of you who are still not sure if you want to participate, you can feel free, but we will need you all who really want to continue by next week to let us know so we can form teams. And we do have a lot of other sessions coming up. Some more high-level webinars to kind of give you all a context of the climate data specifically with some of our international speakers as well. So anybody has any questions? I know we're running on time now. 1 o'clock is our max time. So let's see if we have any question in the chat. Shankar is recommending if any of you all want to look in terms of the fancier machine learning terms, yes, in the icebreaker session, feel free to check this paper that he mentioned here. And also Rihanna is going to send you all our feedback in the chat. So Rihanna, you'll send them the feedback form and we take any questions now before we end off. Anybody has any questions? Thank you for bearing with us with the technical difficulties, and we're really happy to have such a great turnout. Anybody has any questions or concerns? Anything at all? All good? Okay, great. Well, I thank you very much on behalf of my team. Thank our speakers today. They did extremely well. Nicholas, Mercedes, Shankar, and of course, Shannon Ray, our mentor liaison, and Liana is our task manager. We're really happy to have them on board. And we are really happy to have you all participating. Feel free to reach out to us, check us out on the website, join us in the Slack channel, and we'll see you all next week. For those of you who really want to participate and continue, feel free to let us know via email so we could kind of start to formulate the teams and kind of have a context in terms of what you would like to, assist with on the team in that aspect. Thank you, Stephen. We're really happy to know that. So I thank you all. Do have a great rest of your day or night, wherever you are, whichever time zone you're watching this in, and we will see you all virtually in our next session.